The iterator pattern provides a way to access the elements of an aggregate object sequentially without exposing its underlying representation. Let's take an example. Imagine there are two restaurants and both of them have different ways to represent their menu items. One uses one-dimensional array list and the other one uses a two-dimensional array list. And for some reason, these restaurants are getting merged into one. So we need to implement a common interface for these menus so that the menu items can be traversed in the easiest way possible. Let's start with the class diagram. First comes the iterator interface, which contains three functions. The hasNext function tells if there is an object to traverse to. The next function returns that object and moves the pointer forward, and remove function removes that object. From this interface, we can implement concrete iterators, and let's also look at the aggregate objects that we are trying to traverse. All concrete aggregates must implement an aggregate interface, which has a function to create a concrete iterator. Now, if a client wants to traverse over the aggregate object, it will call the createIterator function. With this information, we can create the class diagram for our restaurants. It will look something like this. This kind of class structure decouples the aggregate object and the traversal of that aggregate object. Let's look at the code now. Alright, this is my custom iterator interface, which has the three basic functions that we talked about. And the aggregate object here are the restaurant menus. So both of these restaurant menu implement the menu interface. So the menu interface consists of a createIterator function, which should be standard for all menus. Now let's take a look at the restaurant 1 menu. This menu consists of a list of menu items, while the other one contains a list of menu items. For restaurant 1 menu, the iterator implementation is pretty simple. Since the data type is just a list of objects, the inbuilt list iterator of Java will work just fine. But for restaurant 2 menu, we have to build some custom logic for the traversal. So restaurant 2 menu iterator consists of a global iterator, which will iterate over each list of this data type. And the current list iterator will iterate over the current list in these items. So as you can see here, this is the custom logic for traversal. Now let's try to run this code. So this is my main function. I'm creating two menus with some dummy data. Then I'm trying to create iterators for these menus using the createIterator function. And then I'm simply traversing through the list of menu items using these iterators and printing each one of them. Let's see how it prints out. As you can see here, it prints both of these menus sequentially and traverses through all of the menu items. So in menu 1 we have 4 items, and in menu 2 we have this many items. Let's recap what we learned in this video. All iterators must implement the iterator interface and the set of methods for traversing over elements of a collection. The concrete iterator is responsible for managing the current position of the iteration. Each concrete aggregate is responsible for instantiating a concrete iterator that can iterate over its collection of objects. The client interacts with the aggregate and iterator interfaces only. It decouples from behind-the-scenes implementation. This was all about the iterator pattern, and I'll see you in a bit.